Lesson 9.1, Right Triangle Trigonometry. Our essential question, how do you evaluate trig functions of acute angles? Find unknown side lengths and angle measures of right triangles, and use trig functions to solve real-life problems. There are 6 problems left on the page for independent practice. Let's go ahead and take a closer look at those. So looking at our first problem, this is a right triangle where I do know 2, but I don't know the third side length. I need to know all 3. Which means I'm going to use a squared plus b squared equals c squared to solve for the third. I know the 2 legs, which means I knew a and I knew b. I did not know the hypotenuse, so I don't know c. How do I know that that's the hypotenuse? It's because that is what it's immediately across from the 90 degrees, and immediately across from the 90 degrees is always your hypotenuse. So now we're going to go ahead and we're going to solve for x, because x was the missing side length. So the square root of 233 is our x value. Please do not turn that into a decimal. We want to keep it as a square root. So our hypotenuse is the square root of 233. So I have so, ka, toa. I have a square root in my answer, which means if it turns out to be in one of these answers, I do need to rationalize the denominator. So first, what is opposite and adjacent? We are looking at theta. So here's our theta. Our theta is always immediately across from our opposite and always immediately next to our adjacent. So opposite is 8 all over my hypotenuse, which is the square root of 233. If this is sine, then the cosecant is the reciprocal, square root of 233 all over 8. Cosine is adjacent. Adjacent is 13 all over hypotenuse, which is the square root of 233. If this is cosine, secant is the reciprocal, so it's the square root of 233 all over 13. Tangent is opposite. Opposite was 8 all over adjacent was 13. If this is tangent, cotangent is the reciprocal of 13 all over 8. I have 4 answers that are done that cannot be simplified. These 2 need to be simplified because their denominators need to be rationalized. If the square root of 233 is what is in the denominator, then that is what we need to multiply both the numerator and the denominator by in order to rationalize it. So 8 times the square root of 233 is 8 square root 233 all over square root of 233 times the square root of 233 is 233. 8 and 233 do not have anything in common, so this is my final answer. We have to rationalize cosine as well, because the square root of 233 is what is down in the denominator. Then that means that is who we need to multiply both sides by to rationalize it. 13 times the square root of 233 is 13 root 233 all over square root of 233 times the square root of 233 is 233. So this is my cosine answer. Everybody else was already simplified and rationalized. Let's look at the next one. Right triangle. I know 2 of the 3 sides, which meant I need to do a squared plus b squared equals c squared to find the missing third side. The 2 sides that I know are the legs, so that means I know a and I know b. I need to find my missing c, which is the hypotenuse, and I know it's the hypotenuse because it is immediately across from the 90 degree, and hypotenuse is always immediately across from the 90 degree. So let's go ahead and solve for x. So we do not want decimals. The square root of 1213 is my hypotenuse. My hypotenuse is the square root of 1213. So I have so, ka, toa. Looking at my theta. Theta is the one that's determining who is opposite. Opposite's immediately across, and adjacent is always immediately next to. So my opposite was 22. My hypotenuse was the square root of 1213. If that was sine, cosecant is the square root of 1213 all over 22. Cosine, your adjacent was 27 all over hypotenuse of the square root of 1213. If you use cosine, secant is the reciprocal, so it's the square root of 1213 over 27. Tangent is opposite, which we said was 22, all over adjacent, which we said was 27. This cannot be simplified at all. They have nobody in common. So my cotangent is 27 all over 22. These four are a simplified form. Unfortunately, our sine and our cosine are not in simplest form because their denominators need to be rationalized. So we need to multiply both sides by the square root of 1213 on both of these problems. So this is 22 times the square root of 1213 all over 1213, and that is your final answer. Cosine is going to be 27 times the square root of 1213 all over 1213, and that is your final answer. Let's go ahead and look at the last one. It's a right triangle. I know two of the three sides, which means I'm going to need to know a squared plus b squared equals c squared to find the third side. So I know one leg, so I know A. I need to find B. I do know C because C is always going to be our hypotenuse, which is always immediately across. So go ahead and solving for our missing x value. So x equals 4 root 2. So I've got sine, so I know that's so, ka, toa. Now I wrote them underneath because I realized I've been kind of running out of room trying to rationalize, and I know that there's still a radical in here, so I'm probably going to have to rationalize here as well. So trying to leave room for the rationalization. So sine is opposite. Well, we're doing sine of theta. So here's theta. Here's my opposite, which meant this must have been my adjacent. So opposite was x, which we said was 4 root 2. So my opposite is 4 square root of 2 all over my hypotenuse, which is a 9. That doesn't need rationalized, but I observe that when I come over here and do the cosecant of it, now it needs rationalizing. The square root of 2 is what needs to go away. So I'm going to multiply both the numerator and the denominator by the square root of 2. So I have 9 square root of 2 all over, square root of 2 times square root of 2 is 2. So 2 times 4 is 8. So 9 square root of 2 all over 8. Let's do cosine of theta. So I need my adjacent, which is 7, all over the hypotenuse, which is 9. So my answer is 7 over 9, which means my secant is 9 over 7. Now tangent. Tangent is opposite, so that's 4 root 2, all over adjacent, which is 7. If this is tangent, cotangent needs to be reciprocal, so here is the reciprocal. And the reciprocal needs to be rationalized, so I need to multiply both the numerator and the denominator by square root of 2's. So this is 7 square root of 2 all over, square root of 2 times square root of 2 is 2. That 2 times that 4 gives me an 8. So my answer is 7 root 2 all over 8. Let's go ahead and look at your last three. This is a right triangle with 2 of the 3 sides being known, which means we're going to do a squared plus b squared equals c squared to find the third missing side. I know 2 legs. I know one of the 2 legs, so here is me with the one leg. I don't know the second leg, but I do know my hypotenuse. How do I know that's the hypotenuse? Because that's what's immediately across from the 90 degree. Since this problem gave us decimals, then we can officially use decimals. So let's go ahead and solve for x. So my x is 23.779. So here's my x, 23.779. So now I need to do sine, cosine, and tangent. So I need so, ka, toa. So sine, we're all in relation to theta. Here's theta. What's immediately across from theta is always going to be our opposite, which meant immediately next to theta is always our adjacent. So opposite is 23.779 all over. My hypotenuse is 30.5. We're going to leave the fraction like this because we want to see who opposite was and who hypotenuse was because we want the ratio. So we're going to leave it. We're not going to simplify it. If this is sine, that meant cosecant is the reciprocal. Cosine of theta, I need my adjacent. My adjacent is 19.1 over my hypotenuse, which is 30.5. So the reciprocal is my secant. There's a decimal there. Tangent is opposite. My opposite is 23.779 all over. My adjacent is 19.1. My cotangent is the reciprocal. That's 19.1 all over 23.779. Let's go ahead and do the next one. I know 2 of my 3 sides on my right triangle. So that means I have a squared plus b squared equals c squared. So I know one leg. I do not know the other leg. And I do know the hypotenuse because the hypotenuse is always immediately across from the 90 degree. Let's go ahead and solve for the missing value. So this is the square root of 473. So we have SOHCAHTOA. So sine, well first we're looking at theta. So theta's here, which meant my 16 was my opposite, and my adjacent was the square root. So I need opposite, which was 16, all over my hypotenuse, which was my 27. 16 and 27. 27 do not have anything in common, so that cannot be simplified, which meant my cosecant is 27 all over 16. Well, that's my cosine. I need my adjacent, which is the square root of 473, all over my hypotenuse, which is 27. If that is cosine, that means secant is 27 all over the square root of 473. Because the radical is in the denominator, that means both of these sides are going to have to be rationalized. So my answer is 27 square root of 473 all over 473. Now tangent, I need my opposite, which is 16, all over my adjacent, which is the square root of 473. If that's tangent, cotangent is the square root of 473 all over 16. This one needs to be rationalized. So multiplying both sides by the square root of 473, I get 16 root 473 all over 473. Last one. There are decimals, which meant we can use decimals on our answers. I know 2 of the 3 sides, and since it's a right triangle, I know that I could do a squared plus b squared equals c squared. I know both legs, so here are both legs. I don't know the hypotenuse, and I know this is the hypotenuse because it's immediately across from the 90 degree angle. So let's go ahead and solve for this one. So we just found our missing side, which was our hypotenuse, to be 13.85. So because we want these to be in the ratio still, we're not going to simplify any of the fractions that we get. So here is SOHCAHTOA. So first, theta is the angle we're using. So immediately across from theta is always our opposite. The one immediately next to it is always our adjacent. So opposite was 5.3, all over hypotenuse was 13.85. We're going to leave it like this for now because that shows us our ratio. And then here is cosecant. Cosine, adjacent was 12.8, all over hypotenuse is 13.85. We're not going to simplify this because we want the ratio. Secant then is 13.85, all over 12.8. Tangent is opposite, which is 5.3, all over adjacent, which is 12.8, which meant cotangent is 12.8 all over 5.3.